All right, so in the last video, we calculated what sine of 45 degrees has to be and cosine of 45 degrees. And to do that, remember, we used a special kind of right triangle. What we're going to do now is we're going to see how to calculate sine and cosine of 30 and 60 degrees. Right? Again, we're trying to calculate the trig functions at specific angles. So here, basically, we're going to do 30 and 60 degrees. And as I said before, once you know sine and cosine of 30 degrees, you know all the trig functions at 30 degrees. Same thing with 60 degrees. Okay, so let's consider an equilateral triangle, and we're going to assume all the lengths have side 2. It actually turns out it doesn't matter what you take the side length to be, because the triangle you get will be similar. But for convenience, we're going to take it to be 2. Now, all the sides are equal. And that forces all these angles to equal each other as well. Well, since we're in a triangle, the angles have to add up to 180 degrees, so each angle is actually 60 degrees, as you can see. So now, what I'm going to draw is the line from the top of the triangle to the base, but it's going to be perpendicular to the base. In other words, I'm drawing this line here, the line perpendicular to the base. So this angle and this angle too are each 90 degrees. All right. Well, how does that help us? Well, hopefully it's easy to see that this triangle and this triangle, these are actually going to be congruent to each other. These are actually going to be congruent to each other. In fact, since this angle is 60 degrees, this angle here is 90 degrees, that forces this angle to be 30 degrees. And same thing over here. So we have angle, side, angle. So what we have then is really a 30, 60, 90 triangle. So let me draw that here, like so. So here, let me see if I can draw it a little bit better. So we have 30 degrees, okay. Here's 60 degrees, here's 90 degrees. Okay, as we can see there. So again, this is 2. We have this angle, this angle. Now, since these two triangles are congruent, that means this base here and this base here are actually equal in length. I know it doesn't look like it that much from what I drew, from the way I drew it, that is, but they are actually equal in length. So that forces this side length to be 1. Okay, well, how do we get the remaining side? Well, we use Pythagorean Theorem. So if this is here, let me call this side, I'm going to call it B just for fun. So what do we have? We have 1 squared plus B squared is equal to the hypotenuse, which is 2 squared. So again, this is just Pythagorean Theorem. 1 squared is 1, B squared is B squared, because we don't know what B is. 2 squared is 4. Okay, so from here, of course, we subtract, like so. These cancel. We get B squared is 3. And so from there, of course, we get B has to be the square root of 3. Okay, so now let me draw the triangle one more time. See if I can make it nice. Like so. Here's 60 degrees. Okay, good. And of course, again, this is 90, like so. Good. So what we have then is we have 1 square root of 3 and 2. Well, with this triangle, we can now obtain, using SOHCAHTOA, what sine and cosine of 30 degrees are. So first, let's get the sine of 60 degrees. Well, again, by definition, by SOHCAHTOA, sine of 60 degrees is opposite over hypotenuse. opposite over hypotenuse. So sine of 60 degrees is the square root of 3 over 2. Cosine of 60 degrees, right? That's adjacent over hypotenuse. So that's adjacent divided by hypotenuse. Adjacent divided by hypotenuse. So we're going to have 1 over 2. For 30 degrees, it's actually similar. I mean, you could rotate the triangle, I guess, if you wanted to. Excuse me. But what you could also do is just this. This is the angle 30 degrees, so its opposite side would be this one, 1. So sine of 30 degrees, opposite over hypotenuse, that would be 1 over 2. 1 over 2. So when we say opposite for 30, in this case, for 30 degrees, it's the side opposite the angle. And in this case, the side adjacent to 30 degrees is the square root of 3. So let me see if I have room. Let me see if I can fit it down here. Let's see, I can. Okay, so see if I can fit it. Sine of 30 degrees, again, I just said opposite over hypotenuse, because now it's relative to 30 degrees. So it's 1 over 2. And then cosine of 60 degrees would be radical 3 over 2. In fact, we have the values here. Remember, just like I said before, once you know cosine and sine, you can obtain all the trig functions at that angle. Same thing with 60 degrees. Well, for any angle, actually. Let me just say this, that pi over 6 is 30 degrees in radians. Okay? Pi over 6. So pi over 6 in radians is 30 degrees. Pi over 3 is 60 degrees in radians. I might have misspoke. Let me say it again. 30 degrees in radians is pi over 6. 60 degrees in radians is pi over 3. So that's all I'm doing here. And then again, just like I said a few minutes ago, tangent, remember, we can get all the trig functions in terms of sine and cosine. So we know tangent is sine over cosine. So this is tangent of 30 degrees. And again, it is right to say it's equal to 1 over radical 3. But here, what I'm doing is, let me just get that, is rationalizing. So in other words, I don't want a radical in the denominator. So what I'm doing is, I'm basically eliminating it. Let me show the calculation over here. So what I'm doing is I'm multiplying the bottom by radical 3 and the top by radical 3. So we're going to get 1 times radical 3 over radical 3, radical squared in this case, squared, radical 3 squared, excuse me. So on top, we're going to get radical 3 over 3. And that's what's happening over here. And again, you can get the other trig functions as well. That's what I'm demonstrating here. You know, I'm just using some of the identities that we already have seen. That's all I'm doing here, okay? The notes will be posted if not already, so I'll let you look at that later.